All right, so we're going to prove the alternate interior angles theorem. We are given M is parallel to N. That's that symbol for parallel, and we can see we have some extra arrows to show parallel lines. We want to prove that angle 1 is congruent to angle 2. So sometimes it's nice to think about your plan. How are you going to get there? So we're going to use the same side interior angles postulate to show that angles 1 and 3 are supplementary. Then we're going to show that angles 1 and 2 are congruent because they are both supplementary to the same angle. All right, so let's work this one out. Our first statement, we always start with the given information. M is parallel to N. How do we know that's true? That is given. All right, when you have parallel lines cut by a transversal, same side interior angles will be supplementary. So we can identify angle 1 and angle 3 are supplementary. And we know that from the same side interior angle postulate. Well, if we know that angles are supplementary, we know what that means. It means that they add up to equal 180. So the measure of angle 1 plus the measure of angle 3 is going to equal 180 degrees. That's the definition of supplementary angles. All right, if we look at the picture, so we just said that angle 1 and angle 3 are going to add up to 180. If we look at angle 3, it's right next to angle 2. These two angles will also add up to 180. An angle plus a smaller angle is going to equal the big angle, so we can go ahead and say the measure of angle 2 plus the measure of angle 3 equals 180. That's our angle addition postulate. All right, what we have here are measure of angle 1 plus the measure of angle 3 equals 180, and the measure of angle 2 plus the measure of angle 3 also equals 180. So we have this transitive property that lets us state that means the measure of angle 1 plus the measure of angle 3 must equal the measure of angle 2 plus the measure of angle 3. If this sum is equal to 180 and that sum is equal to 180, then the two sums must be equal to each other. Transitive property. All right, now if you subtract angle 3 from both sides, then we know that the measure of angle 1 is equal to the measure of angle 2. That's your subtraction property. And if the measure of the angles are congruent, then that means angle 1 will be congruent to angle 2. And that's just the definition of congruent angles. If angles have the same measure like they do in line 6, that means that they will be congruent. And we were trying to prove that angle 1 was congruent to angle 2, so we did it.